Okay, so today what we're going to do is just reinforce what we learned last week. I'm going to extend lesson 1 and do a few more examples with you. So the first example is still the two equations with the two unknowns. Again, you can choose any method you'd like. This one looks like it's set up nice and pretty for elimination. So that's what I'm going to do here. Let me rewrite this. So 3x plus 2y equals 4, 5x minus 2y equals 8. Notice my y's have the same number, opposite signs. So when I go to add the two equations, that y is going to cancel out. And I'm left with 8x is equal to 12. Divide both sides by 8. X is equal to 12 over 8. I do need to reduce this fraction. I can divide the numerator and the denominator by 4 and get 3 over 2. Now, again, remember the solution to these systems is in order pair. So I now need to take what x equals and plug it back into one of the original equations. It doesn't matter which. For this one, I'm going to plug it into the first one, which is 3x plus 2y equals 4. I'm taking out x, putting in and substituting 3 over 2. I'm now going to solve, multiply that. I'm going to clear my fraction. You could work with the 9 over 2 and subtract it to the other side, but I'm going to go ahead and clear my fraction. I'm going to multiply everything by 2. So this will give me 9 plus 4y equals 8. Now I'll move the 9. 4y equals negative 1. Divide by 4. And y equals negative 1/4. So the solution to that system is going to be the order pair 3 over 2 or 3 halves, comma, negative 1/4. So that will be the solution to that system of equations. I want to do number 2 on your own right now. I'll give you a few minutes and then I'm going to work it out. Once you finish number 2, I also want you to do number 3. All right, so you're working on number 2. The answer, I'm going to tell you the answer ahead of time, but then I'm going to work it out. The answer is 3, negative 2. So if you're not getting this, raise your hand and I'm going to come around and help you. I'm going to work it out in a minute. When you get to number 3, it's all real numbers or infinitely many solutions. Okay, so for this one, it's not set nice and pretty for you, but you can choose what method you want to do here. I'm going to use elimination again. And again, you can choose to eliminate either x or y, because in this case, I've got to multiply both equations. The way that I'm going to work it out is I'm going to eliminate y. I've seen a lot of students earlier this morning eliminate x, and that's perfectly fine. As long as you get your answer down to the same one that I've gotten, which is 3, negative 2. So I'm going to eliminate y. So I am going to multiply my first equation by 4. So 5x plus 3y equals 9. I'm going to distribute and get 20x plus 12y equals 36. My second equation, I'm going to multiply by 3. And once I do that, I get 6x minus 12y equals 42. I'm going to line them up. And now I can see what's going to cancel. I've made the y's, one have a positive 12, one have a negative 12. So the y's cancel out. I'm left with 26x is equal to 78. Divide by 26, and x is equal to 3. I now need to find the y. I'm going to go back to the beginning. I'm actually going to plug it into the first one. So 5x plus 3y equals 9. 5 times 3 plus 3y equals 9. 15 plus 3y equals 9. Subtract 15. 3y equals negative 6. Divide by 3, and y equals -2. So again, as a coordinate, 3, -2. So go ahead and work on number 3 now. This one, when you finish it, the answer should be all real numbers or infinitely many solutions. So you can work on that. And then I'm going to do number 4 because it's 3 equations and 3 unknowns. And then you're going to work on 5 and 6. If you've already gotten the answer, you can start. So let's try this one. Again, I'm going to do elimination. I'm thinking I'm eliminating x. So I'm going to multiply my first equation by -2. So 2x minus y equals 1. -4x plus 2y equals -2. If I add that to the second equation, notice that the x's cancel, the y's, and so do the answers. So I'm left with 0 equals 0, which is a true statement. So when this occurs and you're left with a true statement, the answer is all real numbers. You could write it as -infinity to +infinity. You can just write infinity. This, infinitely many solutions. You can write it out in words. However you want to indicate that there's infinite many solutions here. All right, so now I'm going to do an example of 3 unknowns. So 3 equations, 3 unknowns. Now, again, like I said on Friday, there's not one set method that you follow. Okay, you need to choose which variable you want to eliminate. Again, try to find the one that's going to be the easiest, that'll involve the least amount of calculations. I'm going to number my equations 1, 2, 3. And now I need to find my one pivot equation or my one equation that's going to be the same in both. And in this particular problem, I'm going to add 1 and 2 first, and then 2 and 3 second. Now, my letter that I'm going to choose to eliminate first, I'm going to choose to eliminate the variable x from both. It must be the same variable in both of your pairs. Now, when you got to the next equation, when you do number 5, the students were asking me earlier, do we always have to keep 2 the same? No, you don't. You could add, I could have added 1 and 2 and 1 and 3, and then 1 would have been my equation in common. As long as you have one equation that's the same in both of the pairs, it doesn't matter. Okay, so let me go ahead. When I add 1 and 2, I don't need to multiply by anything because notice my x's, one's +1, one's -1. So as soon as I add them, those x variables are going to cancel. So that's why I chose that one, because I didn't have to do any calculations here. Just add the 2 equations. So let me write them on top of each other. And then I'm going to add them up. The x's cancel out. And now I'm left with y plus 4z equals 7. Now, when I go to add equations 2 and 3, notice my x's aren't going to cancel. So in order to get them to cancel, I'm going to be multiplying equation 2 by 2. So let me show you that math. So I'm going to take equation 2 and I'm going to times it by 2. So -x plus 3y plus z equals -2. So I'm going to distribute and I get -2x plus 6y plus 2z equals -4. I'm going to write equation 3 below it. 2x minus 5y plus 5z equals 17. I'm going to add them up now. The x's cancel. So I'm left with y plus 7z equals 13. I'm now going to take these two and put them on top of each other. So now I can get a better look at what I want to do here and which variable I want to cancel. So at this point, you can do substitution or elimination. Again, I'm going to choose to do elimination. I'm going to multiply this first equation by -1, and I'm going to eliminate y. So I'm going to distribute the -1, and this gives me -y minus 4z equals -7. Let me move that out of the way. So now I'm going to add the two equations. Notice the y's cancel away. And now I'm left with 3z is equal to 6. Divide by 3. And z equals 2. Now that you have the first piece of your ordered triple, now we're going to go back up. And we're going to plug it in to either the green side or the yellow side. It doesn't matter which. I'm going with the green. It looks like it might be simpler. Again, it doesn't matter. So y plus 4z equals 7. I'm going to put 2 in for the z. Simplify and solve for y. I'm going to move the 8. And y equals -1. Again, this is a triple, not an ordered pair, so I still need to find x. So for x, I'm going back to the beginning. So I'm going to actually plug in both the y and the z into the original equation. I'm going to choose the top one. X minus 2y plus 3z equals 9. Doesn't matter which. This one looked like it was the easiest one. So x, the y is -1, the z is 2, and now I'm going to solve for x. X plus 2 plus 6 equals 9. Add the 2 and the 6. Subtract the 8, and x equals 1. So my ordered triple here, in A, B, C order, X, Y, Z, is going to be 1 for X, -1 for Y, and 2 for Z. So that would be the ordered triple. Again, it's always a good idea, if you have time, where you can plug them back into the originals. If you do not get a true statement, then you've done something wrong, and you need to start all over again. I want you all to try 5 and 6. I'm going to tell you the answers so that way if you're getting them wrong, I'll come and help you and find your mistake. So for number 5, the answer for the ordered triple you should be getting is 3/10 for X, 2/5 for Y, and 0 for Z. For number 6, the ordered triple is going to be 1, -3/2, and 1/2. I'm going to work them out, but I want you to try them right now. And if you're making a mistake and you can't figure out where you've gone wrong, raise your hand and I'll come and help you. Okay, so I'm going to explain what I did for number 5. Let me go ahead and erase these answers, get them out of the way. And I'll put them back on the next slide. So for number 5, what I decided to do is eliminate X. So for this one, I'm eliminating X from both of my pairs. I'm going to add 1 and 2 and 1 and 3. When I add 1 and 2, I need to multiply one of my equations by -1 to get the X's to cancel. So I'm actually going to multiply the first one by -1. So when I do that, I get, so if I times this one by -1 initially, I get -2x minus y minus 3z equals -1. Again, I'm adding that to 2. So I could number these 1, 2, 3. So I'll write 2 below here. Plus 6y plus 8z equals 3. I'm adding my equations. The x's cancel. I'm left now with 5y plus 5z equals 2. I'm going to add equations 1 and 2. However, when I add, 1 and 3, but what I'm going to do is multiply my first equation by -3 to get the x's to cancel. So now I'm going to multiply the first equation by -1. So I'll just go ahead and rewrite it here so you can see it. 2x plus y plus 3z equals 1. Distribute it, and I get -6x minus 3y minus 9z equals -3. I'm going to go ahead and write equation 3 underneath it. And then I'm going to add up and down. So the x's again cancel. I'm left with 5y plus 9z equals 2. I'm now going to take the two equations I just formed and write them on top of each other. So now I can get a better look at which variable I want to eliminate this time. So now I can see that it's probably going to be a lot easier for me to eliminate y. So I'm going to multiply my first equation by -1. Doesn't matter which. So my new multiplied equation, I'll write it underneath. So -5y minus 5z equals -2. Let me move this out of the way. So now I'll add up and down. The y's cancel. And I'm left with 4z equals 0. Divide by 4, z equals 0. Now that I have my first piece of my ordered triple, I go back up and plug it in to either the green or the yellow. Pretty good so far? All right, so now I'm going to plug it in. I'm going to plug it into green. Looks like it might be the easier side to do. So I'm going to take z and I'm going to plug it into the 5y plus 5z equals 2. 5y plus 5 times 0 equals 2. 5y plus 0 equals 2. So 5y equals 2. Divide by 5, and y equals 2/5. I now need to go back to the very beginning and grab one of my equations and plug it in. So I'll take the very first one, doesn't matter which, but this one looks like it's nice and easy. And I'll plug in z and y. So I'm solving for x, so 2/5 plus 3 times 0, 2x plus 2/5 equals 1. I could work with the 2/5 if you'd like. I'm going to clear the fraction. I'm going to multiply everything by a 5. So this will become a 10x plus 2 equals 1. No, equals 5. Subtract the 2. 10x equals 3. Divide by 10. And my x of my ordered triple is 3/10. So the final answer written as an ordered triple, remember ABC order. So 3/10, 2/5, and lastly the 0. So that is number 5. Everyone should have been working on 6. So the answer for 6 again is 1, -3/2, and 1/2. I will work on this one momentarily. All right, so for number 6, again, you need to choose a variable you want to eliminate. Again, I'm going to label my equations 1, 2, and 3. I am going to choose to eliminate x again. I'm going to add 1 plus 2 and 1 plus 3. Now, when I add 1 and 2, notice when I try to eliminate x, I need to make one of these 3's negative. So I'm going to actually multiply equation number 2 by -1. So I'm going to rewrite equation 1. And then for equation 2, I'm multiplying it by -1, so I'm going to flip all the signs to opposite. And now I can add the two equations. The x's cancel, and then I'm left with -2y minus 4z equals 1. I now have to add equations 1 and 3. This one's a little bit more work because notice I've got a 3 and a 5. So I need to make them 15 and -15. So for my first equation, I'm going to multiply it by 5 to make it become positive 15. So I'll distribute 15x plus 15y plus 25z equals 5. And then for equation 3, I'm going to multiply that one by -3. So then that'll give me the -15 that I need. So 9y, 17z equals 0. Distribute the -3, and I get -15x minus 27y minus 51z equals 0. I'm now going to work with these two. I'm going to add them up. So let me write them on top of each other so it's nice and clear for me. So 15y, 25z equals 5, -15x, 25y. And now I'll add them up and down. These cancel. I'm now left with -12y minus 26z equals 5. These two now, I'm going to write them on top of each other. So now I have -2y minus 4z equals 1, and then the -12y minus 26z equals 5. I now need to decide what I'm going to eliminate. I'm going to eliminate y. So I'm going to multiply this equation by 6. So now I get -6 actually. I get positive 12y, positive 24z, and -6. Now I can add them. This is gone, and I'm left with -2z equals -1. Divide by -2, z equals positive half. I now work back up and plug it in. So now I'm going to go up and go green or go yellow. I'm going to go green. So -2y minus 4z equals 1. Plug in 1/2 for the z. So -2y, 4 times 1/2. Half of 4 is 2. Move the 2. -2y equals 3. Divide by -2. And y equals -3/2. Back to the beginning. So I'll do the first one. 3x, 3y, 5z. Plug in the z and the y. The y is -3/2. The z is 1/2. And actually, well, I'll finish this one. Probably one of the other two would have been easier because they were equaling 0. I think I switched my problem on. Hold on. I switched it. Let me fix this. I did not plug it into the first one. I actually plugged it into the second one. So the second one was 3x plus 5y plus 9z equals 0. And I need to change this to a 9 also. because I saw it equaling 0, so I thought that would be easier. So 3x minus 15 halves plus 9 halves equals 0. 3x, and when I add these two, I get negative 6 over 2, which is going to be negative 3. Add the 3. 3x equals 3. Divide by 3, and x equals 1. So again, written as an ordered triple, x is 1, y is negative 3 halves, and z is 1/2. So that is the answer to number 6. So again, be careful, write nice and neatly. The homework is practice of these ordered triple answers. It's 47 through 55 odd. And then tomorrow we will start 9-2 and we will begin working with our matrices. The matrices will be solving systems. Again, we will put the numbers from the equations in, just the coefficients, and we'll be basically combining 2 steps into one. We'll be adding or subtracting and then, or like multiplying and then adding or subtracting. And we're gonna end up getting like ones diagonally. So that is it. So go ahead and you can start your homework.